Welcome to Study Loop.
In this question, we're dealing with how lipid bilayers form spontaneously. And spontaneous means that there's no energy input required for a lipid bilayer to form. So if you put a bunch of phospholipids into solution, they will automatically, spontaneously form a bilayer without the input of energy. That's what spontaneous means. Let's do a quick review of what a phospholipid looks like. Overall, or just real broadly, it has a polar head, which means it likes water, and a nonpolar tail or two nonpolar tails, which do not like water. Okay, and a molecule that has these properties where it has a polar part that likes water and a non-polar part that does not like water is called an amphipathic molecule. So amphipathic means that it has two regions with different properties. Think of amphibian, right? Amphibians are animals that live both on land and in water, right? So that's the root there. So now let's look at how these guys would orient themselves if they were in solution. So let's just start with a real simple picture. If you had two phospholipids, right? You have one guy here, and let's draw another guy in this orientation. So this is case one. And let me draw another case. Here's our first guy, and here's our second guy. Now, these guys, the heads, right, the polar heads, they are polar, hydrophilic, they like water, okay? So if you have water around the lipid, this is a favorable environment for this head, and this is a favorable environment for this head. And for the tails, well, the tails are pointing towards each other, and they are both hydrophobic. So they have both similar properties. Remember, like dissolves like. So polar substances dissolve in polar substances. Hydrophobic substances dissolve in hydrophobic substances. And by dissolve means that you have favorable interactions. Now, in this configuration, in case 2 here, you have a polar group that's oriented close to a hydrophobic group, and this is not favorable because you have a hydrophobic part interacting with a hydrophilic part. So now, if we just zoom out and consider a lot, let me just draw them a little bigger, a lot of lipids in solution, right? If you just drop them there, well, eventually these molecules are going to wiggle and move around due to Brownian motion, and eventually they're going to bump into each other, right? And if they bump into each other in this configuration, they are most likely to stay in that configuration, okay? If they bump into each other in this configuration or any other configuration that's less favorable than the bottom one here, then that will not persist. So this situation here will persist, and then eventually another lipid will sort of bump into these guys. So, and then another lipid will join here, and now this is even a more stable group of lipid molecules. Okay, and in the next step, you can imagine now the membrane can grow. So you have the first two lipids here, and then another one can start and join here. So now you have the nucleation, the beginning of a lipid membrane. So that's why phospholipids form membranes together. It is the process of excluding water, which is a polar substance, from the interior of the bilayer, which is a hydrophobic uh, uh, region. So it is a way to sequester hydrophobic substance from hydrophilic substance to lower the overall energy of the system. So now let's look at our answer choices. Phospholipids are amphipathic molecules, true. So I'm looking at A right now. The polar head faces towards the water, true, and the nonpolar fatty acid faces towards other fatty acids, true. So everything about A is true. So it looks like that's our correct answer. Let's see why the other ones are wrong. Phospholipids are lipophilic molecules. Parts of the phospholipids are lipophilic molecules, right? The fatty acid part is lipophilic, but the molecule itself is lipophilic and hydrophilic. So B is not completely correct in the description of lipids. Phospholipids are amphipathic molecules. I'm looking at C now. That is true. The nonpolar heads face towards other fatty acid tails. No, because so choice C right now that we're looking at is describing this situation right here. And this is not a favorable situation because you have a polar part interacting with a nonpolar part. Synonymous with saying you have a hydrophilic part interacting with a hydrophobic part. So C is wrong. Phospholipid are hydrophilic molecules, and that's also very wrong. They're not hydrophilic molecules. So the only correct choice here is A.